Right, GCSE question of the week, week 16, higher tier. Right, first question, right 54 is a product of its prime factors. If you want to know how to do that one, look on the video 16a, okay, because that was an overlap question that appeared on Foundation also. So we'll start with question 2. Simplify fully, 27 over 64 x cubed y to the power of 9, all in brackets to the power of 2/3. Okay, so we need to know what that power of 2/3 is, how to deal with it, and we need to know how we deal with the fact that we've got a numerator and a denominator. Alright, so first thing to know is that power of 2/3 applies to the numerator and to the denominator, so we can treat them separately. Okay, we'll do the 27 to the power of 2/3, and then we'll do the denominator to the power of 2/3. And the second thing we need to know is that power of 2/3 is in two parts. It's got a power of 1/3, and it's got a power of 2 on the top. So it's like having a root part, which is the 1/3, and a power part, which is the 2. So that power of 1/3 is the same as finding the cubed root of something. Okay, so that's the bit that we'll deal with for a start. Let's do the numerator. So we've got 27 to the power of 2/3. Is the numerator, and that's really telling us to find the cubed root of 27, and then because we've got a 2 on the top as the power part, square our answer. So if we find the cubed root of 27, that's 3, because 3 times 3 times 3 makes 27. That would be the cubed root of 27, but we've got like 2 on the top, so that's still there. That's still a power of 2, okay, so we've got to do 3 squared. So 27 to the power of 2/3 is the same as 3, the cubed root of 27 squared, which is equal to 9. So that's done the numerator. And the denominator, we're going to apply that power of 2/3 to the 64, the x cubed, and the y to the power of 9. Let's do them all in bits. 64 to the power of 2/3. Okay, because that power of 2/3 applies to everything on that denominator. Okay, we're going to do it in the same way. So we'll find the cube root of 64, that's 4, because 4 times 4 times 4 makes 64. And we've still got that 2 on the top, which is the power of 2 squared. So we've got the cubed root of 64, 4 squared, which is 16. Okay, now we could deal with the x's and the y's. Okay, so the variables. Okay, we've got x cubed to the power of 2/3. Now we can approach this one in a similar way to we did the ones above, but it's probably simpler just to use our index laws, because we should know that when we've got a power to a power, in other words a bracket, a power in a bracket with another power outside it, a power to a power, okay, we multiply those two indices. Okay, so we can multiply the indices. This is going to be the same as x to the power of 3 times 2/3, and 3 times 2/3 is 6/3, which hopefully you can see is 6 over 3 is just 2. So that simplifies down to x squared. Okay, now you could have thought about that in the same way that we did the top one. So we could have found the cube root of x cubed. Well, that's going to be x. And then square that, we get x squared. Okay, let's do the other variable, y to the power of 9 to the power of 2/3 in the same way. So we know it's y to the power of 9 times 2/3, or 18 over 3. Okay, and I make that y to the 6. And we could have thought about this one in the same way as well. It's slightly trickier. The cube root of y to the power of 9. Well, that would have to be y cubed, because y cubed times y cubed times y cubed makes y to the power of 9. And then we've got y cubed squared. Okay, so we've got y cubed squared. We then multiply those indices. That would give us y to the power of 6. Alright, so we've done all our bits individually, we just now need to put them together. So what have we got? We've got the 9. Let's put it down here and then we'll start again. We've got the 9, which was the 27 to the 2/3, over. And then we had 16, which came from the 64 part. And then we had x squared y to the power of 6. Okay, so we can't simplify the 9/16 anymore, otherwise we could cancel down a bit. That's as simple as we can get. So we've got 9 over 16 x squared y to the 6. Right, let's write that answer back up here so I can rub it out. get more space and we'll do it all on the same page. 9 over 16 x squared y to the 6. Right, now just before we move on, occasionally it might be even worse and you might get to the minus 2/3. Okay, and in that case we can do all the steps we've just done and then that minus would flip our fraction. So we'd end up with 16x squared y to the 6 all over 9. Okay, so just to be aware of that, but that's not our question here. Right, I'm going to move that one. So we've got a bit more space and we'll try question 3. Show that 4 plus 2 root 2 all over 2 minus root 2 can be simplified to 6 plus 4 root 2. Right, let's have a go. Okay, the first thing you do with these is rationalise the denominator. Okay, and you need to know the rules for that. If we just had root 2 on the bottom, we'd multiply the numerator and the denominator by root 2. When we've got 2 minus root 2 on the bottom, the rule's a bit more complicated. Okay, we're going to multiply by 2 plus root 2. And we'll always do that. We'll reverse that sign in the middle, leave the rest the same, and you'll see why in a minute. If we multiply the denominator by 2 plus root 2, we've got to multiply the top by 2 plus root 2. Okay, so let's give that a go. That means on the numerator we've got 4 plus 2 root 2 multiplied by 2 plus root 2. And on the bottom we've got 2 minus root 2 multiplied by 2 plus root 2. Okay, so we now need to either FOIL it or grid method it, whichever method you choose. Same for the numerator and the denominator. Okay, so if you're foiling it, we're going to do first, that's going to be 8. We're going to do outers. It's going to give me 4 root 2. We're going to do inners. That's 2 times 2 root 2, which is 4 root 2. And we're going to do last, which is 2 root 2 times root 2. I'm just going to write that as it is for a minute. 2 root 2 times root 2. And then our denominator. Oh, came back. Okay, so we do the same thing. We're going to do first, if you're foiling, that's 4. We're going to do outers, that's plus 2 root 2. We do inners. Ooh, that's minus 2 root 2. Now this is the whole reason that we multiply by 2 plus root 2. We reverse that sign so that we've got 2 root 2 minus 2 root 2. Those roots, the surds, are going to cancel on the bottom. And finally we've got minus root 2 multiplied by plus root 2. So that's minus root 2 root 2. And again, I'll write them both in for now. So now we need to do some simplifying. I'm going to run out of space, aren't I? Let's do that under here, but we might need to go to the left in a minute. So we've got 8 plus 4 root 2 plus 4 root 2. Let's leave that for a minute. That's 8 plus 8 root 2. 4 root 2 plus 4 root 2 is 8 root 2. And then what's this thing we've got over here? Well, we've got 2 times root 2 times root 2. Well, root 2 times root 2 is just 2. Okay, so 2 times root 2 is going to be 4. Right, bottom, denominator, we've got 4 plus 2 root 2 minus 2 root 2, they cancel out as nothing. So we've got 4 minus root 2 times root 2. Now again, root 2 times root 2 is 2. So things are looking simpler. Right, I'm going to whiz over to the left. Okay, so we've got equals on the numerator 8 plus 4, that's 12, plus 8 root 2, and a nice 2 on the denominator. Okay, so I'm getting somewhere. Right, we've got to show that what we started with can be simplified to this. Now, you might be able to spot that that looks pretty similar. 6 plus 4 root 2 on the top, we've got 12 plus 8 root 2, but everything is then divided by 2. Okay, so remember, that's the same as 12 over 2 plus 8 root 2 over 2. Okay, exactly the same thing. That might make it easier for you to see what we're going to do next, which is just divide both of the terms on the numerator by 2, which is going to give us 6 plus 4 root 2. Woohoo! Okay, if you can do those, well, very well done.